The question says to solve the system of equations using matrices. And the system of equations is x plus y plus z equals 4, x minus y plus z equals 2, and 2x plus 2y minus z equals negative 4. Now, in order to use matrices, we first have to write the coefficients in a matrix. So the coefficients of the first equation is 1, 1, and 1. And then we draw a line that tells us after the equal sign it's 4. So we have a coefficient of 1, 1, 1. So as long as we're in terms of x, y, and z in that order, we have coefficient 1, 1, and 1, and 4. In the second equation we have 1, negative 1, 1, and 2. So we get the second row of the matrix. And then the final row is 2, 2, negative 1, and negative 4. Now, whenever we look at matrices and solving a system of matrices, we can either multiply or divide in any row. We can add or subtract between each of the rows. But we must remember to perform the same operation to the entire row. We want to do it to the entire row. The goal is to end up with a matrix of ones along the diagonal. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So ones along the diagonal. And then after the line, we just want any number. So after the equal sign, we'd have any number. So that gets us in the form of x is going to be equal to some number, y from our second row is equal to some number, and z in our third row is equal to some number. So it can equal any number. That's our goal, is to get ones along that diagonal. So let's begin. Let's take a look at the matrix that we started with. Now what we're trying to do is get zeros anywhere except for the diagonal. We just want ones along the diagonal and any numbers here. So let's first add rows 1 and 2 together and write the result in row number 2. So when we add the rows together, so we're going to add row 1 and row 2 together, and we're going to write the result in row number 2. So we get 1 plus 1 is 2. We get 1 minus 1 is 0. 1 plus 1 is 2. And 4 plus 2 is 6. And we just leave the other rows the same as what they were. So we're just leaving the other rows as they were, and then just adding rows 1 and 2 and writing the result in row 2. Now in red you see that I have multiplied row 1 by 2, the entire row by 2, and we're going to multiply row 3 by negative 1. So doing so, we get 2 times 1 is 2, 2 times 1 is 2, 2 times 1 is 2, and 2 times 4 is 8. We leave the second row alone, and then the third row is going to be multiplied by negative 1. So we have negative 2, negative 1 times 2 is negative 2, negative 2, positive 1, and positive 4. Now with that, if we add rows 1 and 3, so we're going to add rows 1 and 3 together, and then write the result in row number 3, what you'll start to see is we're going to get zeros down here in the third row. So in doing so, let's add rows 1 and 3, and let's write the result in row number 3. So we keep the rows the same, 2, 2, 2, and 8, 2, 0, 2, and 6, and now we're going to add rows 1 and 3 together. Well, if we add 2 minus 2, we'll get 0, 2 minus 2 will get 0, 2 plus 1 will get 3, and then 8 plus 4 is 12. Now what we're going to do is we're going to multiply row 1 by 1/2, we'll multiply row 2 by 1/2, and we'll multiply row 3 by 1/2 so we can reduce our matrix even further so we don't have to deal with large numbers later on. So I'm going to end up with a new matrix of 1, 1, 1, 4. 1, 0, 1, 3, and 0, 0, 1, 4. Okay? This we're going to multiply by 1/3 rather, excuse me. Should be 1/3. So we're going to get 0, 0, 1, and 4. So we're dividing by 3 so that we can reduce or factor out. So simplifying down, as I said, we have this new matrix. 1, 1, 1, 4, 1, 0, 1, 3, and 0, 0, 1, 4. Well, now we're going to multiply row 2 by negative 1, so that'll help us get some zeros in the other places. So rewriting the second row and leaving all the other rows the same, we'll get negative 1, because negative 1 times 1 is negative 1. Negative 1 times 0 is 0. Negative 1 times 1 is negative 1, and negative 1 times 3 is negative 3. Leave the other rows the same. Now let's add rows 1 and 2 together, and then let's write the result in row number 2. Well, leave the first row the same, and leave the third row the same. So we're going to add rows 1 and 2 together, and we're going to write the result here. So 1 minus 1 is 0. 1 plus 0 is 1. 1 minus 1 is 0. And 4 minus 3 is positive 1. Now let's multiply row number 2 by negative 1. So the result we'll get, and leave all the other rows the same, so the result we'll get is negative 1 times 0 is 0. Negative 1 times 1 is negative 1. Negative 1 times 0 is 0. And negative 1 times 1 is negative 1. Now what you'll start to see is we can reduce the rows even further, because again our goal is to get 1s along the diagonal and everywhere else is 0. So let's add rows number 1 and number 2 and write the result in row number 1. So let's add rows 1 and 2. So we're going to add rows 1 and 2 and write the result in row number 1. So we're left with 0 plus 1 is 1, negative 1 plus 1 is 0, 0 plus 1 is 1, and negative 1 plus 4 is 3. Leave the other rows written the same way. And now let's multiply row number 1 by negative 1. So I get negative 1, 0, negative 1, negative 3. Leave all the other rows the same. Now from here, we're going to add rows 1 and 3, and then we're going to write the result in row number 1. So if we add the results from row number 1 and row number 3, and we're going to write the final result in row number 1, we'll get 0 plus negative 1 is negative 1, 0 plus 0 is 0, and 1 minus 1 is 0, 4 minus 3 is positive 1. Now remember, we're just trying to get positive 1s along the diagonal. So if we multiply, or if you wanted to divide by negative 1 to get positive, then we can do that. So we're going to multiply row number 1 by negative 1, and we're going to also multiply row number 2 by negative 1. So and the result is going to be 1, 0, 0, negative 1. In the second row, we're going to have 0, 1, 0, 1. And then we're going to have 0, 0, 1, and 4. So you see we've ended up with 1s along the diagonal as our final result, which was our goal, and any number along the right-hand side past the vertical line. So you can see that the final answer, remember, is x. 1x is going to be equal to negative 1. 1y is going to be equal to positive 1. And 1z is equal to positive 4. So the final answer is x equals negative 1, y equals 1, z equals 4. Or if you prefer to write it as a coordinate in three-dimensional space, remember three-dimensional space is x, y, z format. So we can write it as negative 1, 1, and 4. Final answer. Now there's many ways to solve these matrices. You could have added different rows together, but the ultimate goal is to get 1s along the diagonal and any number to the right.